Greetings, gentlemen. Welcome to the Smart Video Lab, and thank you for taking the time to watch this video and to do the most that you can to be prepared for the test and to understand math. So thanks again for joining me. I'm going to go over problems 27 to 29 from the test review on this video. This is a lot of review from chapter 3. So some questions like this will be on the test on Monday or Tuesday, depending on which class you're in. So for A day, that's Monday. B day, that's Tuesday. So for taking the time to watch this video, my present to you, Merry Christmas, is 3 extra credit points. All you have to do on Monday is, at the top of your test, write NC State somewhere, just like this. And I'll give you 3 extra credit points. And don't tell anyone else who didn't want the video, because they didn't earn it. Sorry, watch the video. So number 27, it says the Arctic temperature decreases as you move further inland towards Santa's workshop at the North Pole. It decreases approximately 1.5 degrees Celsius for each kilometer you move inland toward the North Pole. So we land in Antarctica, and we're walking towards Santa's workshop. So we're walking inland. The temperature is going down 1.5 degrees Celsius every kilometer closer we get to the North Pole. So complete the table below showing the temperature in degrees Celsius as a function of the distance traveled inland. Assume the initial temperature where you begin your journey is 10 degrees Celsius. So we begin our journey. We haven't traveled anywhere inland at 0 kilometers traveled. That's going to be 10 degrees Celsius at the start. Now, it says it decreases approximately 1.5 degrees Celsius for each kilometer we move inland. So it might be tempting to say, oh, the next value is going to be 8.5. But notice that on the distance traveled, the table is going up by 4s. So it's like we skip the values 1, 2, and 3 in the table. So from 0 to 4, each time we go up 1 kilometer, we'd be going down 1.5 in temperature. So that's a total of 1.5 times 4. 6 degrees Celsius that we go down. So 10 minus 6 is 4 degrees Celsius. Subtract 6 again, that's negative 2 degrees Celsius. Subtract 6, that's negative 8. Subtract 6, that's negative 14. And subtract 6, it's negative 20. That's cold. So now we want to write a now next rule. So our rule is going to be next equals now. And then we ask ourselves, how much is it changing for each kilometer, for each x? Change in x of 1, a change in y, or change in temperature is going to be minus 1.5. And we started at 10. So to write a function rule, we're going to write a rule in slope-intercept form. Y equals mx plus b, except instead of y and x, we have t and d. So it's going to be 10, our starting value, minus 1.5 degrees Celsius, the amount of decrease. So that's 1.5 times the distance traveled inland. So the rule is t equals 10 minus 1.5d, or you could write that as t equals negative 1.5d plus 10. So the y-intercept here, sorry, I lost my place. The y-intercept here represents the starting value of 10 degrees, and the slope of negative 1.5 represents our rate of change. Now the graph that represents this situation is going to have to be graph 2, because it is the only graph with a negative slope. I don't know why this pen is messing up. Only graph with negative slope. Come on, pen, please work. There we go. So that is number 27. Now in 28, we've got Nicole measured the temperature of water in a beaker as it is heated. After drawing a scatter plot of her data, Nicole drew a modeling line that fit the data well. Her line showed how the temperature of the water changed over time. The function rule for a line was t equals 15 plus 0.5 s times s. where T is the temperature in degrees Celsius after S seconds. So first we want to draw Nicole's modeling line on the grid below. So we've got a function rule in slope-intercept form. So this is our y-intercept. And this is our slope. So I'm going to make a note of that over here. Y-intercept is 15. I don't know why this is happening. Come on. And the slope is 0.5. Which, if I wrote that as a fraction, would be 1/2. So the nice thing about a fraction is I can actually write 1/2 in a variety of ways without changing the value. So 1/2 is the same as 2/4, which is the same as 8/16, which is the same as 10/20, which is the same as 15/30. All of those are different ways of writing 1/2. So we'll keep that in mind when we plot the line. So to draw Nicole's modeling line on the grid below, we want to start with the y-intercept of 15. So my y-scale is 10, and between 10 and 20, there's 15 right there. So that's my starting point at the y-intercept. Now the slope is 1/2, but because of our scale, I'm going to use 1/2 written as 10/20. So I will go up 10 and over 20. Because slope, when seen on a graph, is rise over run. So I rose 10 and I ran 20. That allows me to plot the next point on the graph. And I'll rise 10, run 20, rise 10, run 20, rise 10, run 20, rise 10, run 20, until I have enough points to extend that line. And that is a nice, good-looking graph. I want to explain the method we used to draw the line. So what we did there was we started with y-intercept. This pen is really being strange. So we started with the y-intercept, intercept, and then use rise over run to graph points. And the specific rise over run we used was 10/20, which again is 1/2, which is the slope that we needed. So you could have used 50/100, any rise over run, as long as it simplifies to 1/2. So what does the 15 tell us about Nicole's rule? Or what does the 15 in Nicole's rule tell us about the situation? It tells us that the starting temperature in her beaker was 15 degrees Celsius. And what does the slope tell us? The 0.5. Let's think about units. The y scale is degrees Celsius. X scale is seconds. So change in y over change in x. The slope of 0.5, that's in degrees Celsius per second. So that means the temperature increases 0.5 degrees Celsius every 1 second. And going on now to number 29. Patrick and Mitchell rent movies from the town video store. The graph below indicates the total amount of money spent on videos rented within a year. If Patrick pays an annual fee and Mitchell does not, which graph would correspond to Patrick? Explain your reasoning using what you see in the graph. So Patrick pays an annual fee, which means when he's bought no movies, in other words, anywhere here on the y-axis, when he's bought no movies, he has to pay some cost, some annual fee. So the only graph that fits that is this, because it has a positive y-intercept. So that is the members graph. So our explanation is that's the only graph with a y-intercept. So it's the only one that makes sense. Now we want to find the slope of the non-members line. So remember, slope is always change in y over change in x. On a graph, we can best find that by finding the rise over the run. But in order to do that, we first have to find some nice points on the graph. So we want the non-members line, which is the dotted black line. So here's a nice point on that line, and here's a nice point on that line. So let's see what the rise is and what the run is. So it looks like I rise 50 because of my scale. Y scale is 10, my X scale is 5, so this will be a run of 15. So my slope is rise over run, 50 over 15, which is 3.3 repeating. I'll round to 3.33. So the slope of that line is 3.33. Now what are the units of that? The Y units are dollars, X units are movies. So that gets us into the explanation of the slope. The slope means every movie rental costs $3.33 for non-members. So for a non-member to rent 3 movies, that'd just be 3.33 times 3, which is 10. So thanks again for watching this video. Don't forget to write NC State on the top of your test for your 3 extra credit points. You guys are all champions. Have a great weekend.